Deep inside the sarcophagus, something stirs. Sensors detect anomalies. Radiation levels fluctuate in patterns that should not exist. And on the walls, in pools of contaminated water, something grows. Something black. Something alive. This is the story of the Phantom Zone, the mystery of Reactor 4, where life has found a way in the most unlikely place, where the line between living and dead, between possible and impossible, has blurred. Close your eyes. Let us descend into the darkness, into the reactor, into the zone where reality bends and strange things happen that science struggles to explain. In 1991, 5 years after the disaster, remotely piloted robots entered the ruins of Reactor 4. They navigated through collapsed corridors and shattered rooms. They photographed the devastation, measured radiation levels, mapped the wreckage, and they found something unexpected. On the walls of the reactor, growing in places where nothing should survive, was a black fungus, not just surviving, thriving, growing toward the areas of highest radiation as if drawn by some invisible force, growing in patterns that seemed almost deliberate, almost intelligent. The scientists who examined the samples were baffled. This was not normal fungal behavior. Fungi avoid radiation. Radiation destroys cellular structure. It breaks DNA. It kills. But this fungus, Cladosporium sphaerospermum, was different. It was not merely tolerating the radiation. It was feeding on it. Teams from the Kyiv Institute of Microbiology and Virology began regular visits to the exclusion zone in the 1990s. They collected samples. They studied the organisms. They found more than 200 species of fungi living in and around the reactor. Many of them were melanized, dark, black, rich with the pigment melanin that in humans provides protection from ultraviolet light. But in these fungi, melanin did something more. Something unprecedented. It absorbed ionizing radiation and converted it into chemical energy. The process was called radiosynthesis, like photosynthesis but with gamma radiation instead of sunlight. Life finding energy in what should only bring death. The implications were staggering. If fungi could harvest energy from radiation, could other organisms? Could life exist in places previously thought impossible? The discovery opened doors to questions no one had thought to ask. But the fungi were only the beginning of the mysteries inside Reactor 4. The sarcophagus, built in 1986, was a rushed construction. It was never meant to be permanent. It was meant to buy time, to contain the radiation while a better solution could be developed. But inside that concrete and steel shell, conditions were harsh. Water leaked through cracks. Temperature fluctuations stressed the structure, and the radiation continued to decay the materials, making the sarcophagus itself radioactive over time. Workers who entered the sarcophagus to inspect and maintain it reported strange phenomena. Radiation meters that spiked without explanation. Hot spots where radiation levels were far higher than expected, in places that made no sense. Electronic equipment that failed in ways that could not be attributed to radiation damage alone. And there were the signals, faint electromagnetic pulses detected by monitoring equipment, patterns that repeated, frequencies that seemed to originate from deep within the reactor core itself. Scientists attributed them to electrical activity from damaged equipment, to residual reactions in the radioactive materials. But the patterns were irregular, unpredictable, almost as if something was broadcasting from inside the tomb. In 2007, researchers sent robots deeper into the reactor than ever before. They collected samples from areas that had been inaccessible, and what they brought back challenged assumptions about what could survive in extreme environments. The black fungi had melanin concentrations far higher than fungi found outside the exclusion zone. They had adapted, evolved, changed in response to the radiation. 20% of the fungal species collected were radiotrophic, actively growing toward radiation sources. They were not just surviving, they were flourishing. Laboratory tests confirmed the impossible. When exposed to radiation levels 400 times higher than background, the fungi grew faster than control samples kept in normal conditions. The melanin in their cell walls changed its electronic structure when irradiated, becoming 4 times more efficient at electron transfer. The fungi were using radiation as an energy source. But how? The exact biochemical mechanism remained unknown. Researchers could observe the effect but could not explain the process. The fungi were doing something that violated conventional understanding of cellular biology. They were performing a kind of metabolism that should not be possible. And then there were the observations that no one could quite explain. The stalkers, workers who surveyed the inside of the sarcophagus for damage, reported seeing the fungi in places they should not be able to reach, growing on surfaces that were inaccessible, spreading through sealed chambers, as if the fungal networks extended through the structure in ways that defied physical barriers. Some stalkers spoke of patterns in the fungal growth, not random colonization but almost deliberate arrangements, spirals, networks, formations that seemed too organized to be natural. When questioned, the stalkers would often recant, saying it was tricks of light or exhaustion or the stress of working in such dangerous conditions. But the stories persisted. The monitoring systems inside the sarcophagus detected other anomalies: temperature fluctuations that did not match decay heat calculations, moisture levels that varied without corresponding changes in external weather, and the signals, always the signals, electromagnetic pulses at frequencies that seemed to spike during certain times, then fall silent for days or weeks. In 2016, the new safe confinement was completed. The massive arch was slid over the old sarcophagus, sealing Reactor 4 beneath layers of steel and concrete. The structure was designed to contain the radiation for 100 years, to provide a workspace for eventual dismantling of the reactor, to monitor conditions inside with sensors and cameras. And the sensors detected something strange almost immediately. Radiation levels inside the confinement were not static, they fluctuated, not dramatically, not in ways that suggested structural failure or leakage, but in patterns, cycles, as if something inside was affecting the radiation field. Scientists offered explanations: decay of radioactive isotopes, movement of contaminated water, settling of debris, all plausible, all reasonable, but the patterns did not quite match what the models predicted. There were variations, anomalies, small discrepancies that individually meant nothing, but collectively suggested something more complex was occurring. The fungal colonies continued to grow. Samples collected in recent years show that the radioactive species have not only survived, but expanded their range within the structure. They have colonized areas that were previously thought too contaminated for any life. They coat walls in thick black mats. They form biofilms in pools of radioactive water. They digest graphite from the reactor core itself, breaking down hot particles that remain lethally radioactive decades after the explosion. NASA became interested in the fungi. If organisms could thrive in Chernobyl's radiation field, perhaps they could survive in space. In 2016, samples of Cladosporium sphaerispermum were sent to the International Space Station. Experiments were conducted to test whether the fungi could protect against cosmic radiation. Early results were promising. The melanin-rich fungi reduced radiation exposure by measurable amounts. It was theorized that a 21-centimeter thick layer of the fungus could deflect most of the annual radiation dose received on the surface of Mars. The implications for space exploration were profound, but back on Earth, questions remained about what was happening inside Reactor 4. The fungi were documented, the radiation levels were measured, but the electromagnetic signals, the temperature anomalies, the fluctuations in radiation patterns, these remained unexplained. Some researchers suggested that the fungal colonies themselves might be generating electromagnetic activity. Fungal networks are known to conduct electrical signals. In normal conditions, Fungi use electrical impulses to communicate and coordinate growth. Could radiotrophic fungi, feeding on ionizing radiation, be generating more powerful signals? Could their networks, sprawling through the reactor structure, be creating detectable electromagnetic fields? It was speculation, but it was speculation based on observed phenomena that had no better explanation. In 2022, during the Russian occupation of Chernobyl, monitoring systems detected radiation spikes across the exclusion zone. Initial reports suggested that military vehicles had disturbed contaminated soil, resuspending radioactive particles. But when the data was analyzed, scientists found a different explanation. The base station receiving wireless signals from the monitoring network had been disrupted. The apparent spikes were transmission errors, not actual radiation increases. But the incident highlighted how little was truly understood about the zone, how fragile the monitoring systems were, how easily data could be misinterpreted, and it raised questions about what other phenomena might be occurring that were not being detected or were being incorrectly attributed to known causes. The workers who maintain the new safe confinement speak carefully when asked about their experiences inside. They follow protocols. They wear protective equipment. They work in shifts to limit exposure. But in private conversations, some admit to unease, to a feeling that the structure is not quite empty, that something is happening in the depths they cannot see. They speak of sounds that do not match explanations, clicks and pops that are attributed to thermal expansion but occur in patterns that seem too regular, echoes that suggest spaces larger than the blueprints indicate, and occasionally, very occasionally, a smell, earthy, organic, the smell of growth, the smell of life in a place that should be dead. The radiation inside parts of the reactor remains lethal. In the worst areas, exposure would kill a human in minutes. The elephant's foot, the corium flow that solidified in the basement, still emits radiation at levels measured in hundreds of sieverts per hour. Standing near it unprotected would mean death within an hour. And yet the fungi grow there, on its surface, feeding on the very radiation that would destroy any other known form of life. Scientists continue to study the radiotrophic fungi. Papers are published, conferences held. The mechanisms of radiosynthesis are slowly being understood. Melanin's role as both shield and energy transducer is being mapped at the molecular level, but mysteries remain. The full extent of fungal colonization inside the reactor is unknown. The sensors can only detect what they are designed to detect. And there are areas, deep within the structure, that remain unexplored and perhaps unexplorable. There are theories about what might exist in those depths. Some scientists speculate that entire ecosystems might have developed. Bacteria, fungi, perhaps even simple multicellular organisms, all adapted to life in extreme radiation. Evolution compressed into decades instead of millennia, driven by the intense selective pressure of a radioactive environment. Others suggest that the electromagnetic signals might indicate something more exotic. Cherenkov radiation, the blue glow emitted when particles move through a medium faster than light travels in that medium, is visible in reactor cooling pools. Could similar phenomena be occurring inside Reactor 4, generating detectable signals? Could the movement of radioactive particles through water and air be creating electromagnetic fields that sensors mistake for equipment malfunction? Or perhaps the signals are exactly what they appear to be: echoes of the disaster, electrical activity from damaged systems that have somehow remained partially functional for decades, ghost signals from a dead machine, transmitted automatically by circuits that do not know they should have failed long ago. The truth is that no one knows with certainty what is happening in the deepest parts of Reactor 4. The radiation prevents thorough investigation. The structure prevents access. And the complexity of the radioactive decay processes, the chemical reactions, the biological activity, all occurring simultaneously in an environment never before encountered, creates a system that defies complete understanding. The phantom zone exists not because of supernatural forces, but because of the intersection of radiation and life in ways that challenge conventional biology. The black fungi growing on the reactor walls are real. Their ability to harvest energy from gamma radiation is documented, but the full implications of their presence, the extent of their networks, the effects they might have on the radioactive materials themselves, these remain subjects of ongoing research and quiet speculation. At night, when the exclusion zone is silent and the monitoring equipment hums in its sealed rooms, the sensors continue their vigil. They measure, they record, they transmit data to computers that analyze and archive. Most of the data is routine, expected, but occasionally there are anomalies, spikes in electromagnetic activity, patterns in the radiation field, signals that appear and disappear without explanation. The scientists review the data. They check for equipment malfunction. They calculate decay rates and thermal dynamics. And most of the time they find explanations. But not always. Sometimes the data suggests something is happening inside Reactor 4 that current models cannot fully account for. Something at the edge of understanding. Something in the phantom zone where the known and unknown blur together. Tonight we remember that nature is more resilient than we imagine, that life finds ways to survive in places we declare impossible, that even in the heart of a destroyed nuclear reactor, in radiation levels that should sterilize all existence, life persists, changed, adapted, strange, but alive. The fungi grow in the darkness. The sensors detect their signals. And deep inside the sarcophagus, in places no human may ever see again, the phantom zone continues its slow, strange evolution. Let us rest now, here at the boundary between the known and the unknown, where science meets mystery and the darkness holds secrets that may never fully be revealed. Sleep well.